Anything else? CCTV cables, all the electrical stuff. Schools, you'll have acoustic systems. Acoustic arresters will be there. M&E ducts, mechanical, electrical ducts. Sometimes you'll have cooling systems. I don't know what the purpose of it is. Maybe you have cooling systems. So it is complex. It's not just the brick stuff that you're seeing. So first of all, you need to find a way of taking them apart. If you fuse everything like what you do here, taking everything needs energy. You will need to break it down to take everything out. And when you take it out, it won't be usable. So if you look at the electrical socket, it has metal inner lining. Okay, that's highly recyclable. But by the time you take it away from it, it's hardly usable format. It will need to be forced out of it. Okay. But is there a different way of taking it out so that you can use it better? Would have been better instead of metal? Metal is recyclable, so it's not a problem. It depends then on how we fit it. If it is custom fit very nicely, you can take it apart without damaging it, and then you can reuse it. Also, that means you need to put better metal or shield. Okay. So that level of cyclic thinking will help you to decide how you're going to take your building apart. And you also need to have a manual of how you're going to do it, because this is not complex. Certain structures are extremely complex. I'm going to show you some of the reasons why we have to do it. In the UK, we're not allowed to do that, and the leach coming out of the landfill is extremely controlled. If the leachate will have all sorts of elements in it, metals, ions, things that shouldn't be there, and they do monitor that on a regular basis. And there's a lot of environmental lobbyists with sophisticated techniques, and they will find it if anything has been breached. So they line, then they take it out and they process it and then they dispose it. So that's the story of landfill sites. So even landfill sites are controlled quite well. And obviously there's a lot of resistance on landfill site. Nobody likes landfill site in their neighborhood. Nobody. You can't blame them. Same as in the UK. Some of the older figures shows one good thing about UK is they have statistics. They have a system to record everything. So they know how much of materials has been disposed. It's relative, but they have a quantitative of it. And therefore they know what actions they can take. Every now and then we get a program by the UK government issuing a program on reusing certain part of it. So that'll be a focused research program, and you can go and do the program, and then they will take all the information, pass it to the industry and say, go and do it. So giving a cross section of the country, concrete, bricks, blocks, aggregates, clearly a large portion of it. We're quite a concrete country. Metals, plastics, boards, everything else. We have composite construction, composite in a different angle. So it's a two-layered wall structure that we have. This is the outer layer, basically like a rain guard or a weather guard. There's a cavity, there's an insulation, high performance insulation quite often, and then an inner structural layer. This is the cross section of a house if you look at just the wall. And then at this end of the wall, to make it really finish, because remember labor is very expensive for us, so to finish it we put gypsum board or plasterboard, and that'll be done 4 screws. It'll be done, so no plastering is done. So it's just random, very fast. So when they take it, they know they will get this many plasterboards from it, and plasterboards are recycled by the company that manufacturing it. So you bring it back to them, they will give certain new products back. So it's the same system. It can be tried. I just wanted to highlight those things. It's not important we look at only of these. To do that, That's what we were talking about earlier. To do that, we need to move from linear thinking, which is resource, landfill, to more of a cyclic thinking. As many cycles as you can have of a product, lower will be its carbon footprint. Okay? That's it. It's very simple logic. The only thing is you need to look at that closed loop thinking when you're at the inception stage of the project, before you have conceived the project and complete. Okay? And this is one method of life cycle management, where you think everything in cycles, in circles. And in doing that, you're trying to reduce the value, increasing the value of the project, and also reducing the impact, environmental impact. UK Treasury requires you to look at that kind of hierarchy for waste. Prevention is the first part of it. Reuse, recycling, recovery, disposal. As you come down, the cost increases. So this is why I was saying disposal for us is £75 per tonne, because Treasury requires you to put a high levy on it. Extraction itself has a levy. So for us to take 1 tonne of aggregate, we pay nearly £2.5 of environmental levy. That money will be used to put the structure back, put the area back to its natural beauty. Anyway, all of these have a mathematical meaning. When we did the life cycle calculation, if a value material can be recovered, you get money back. Steel you can recycle, scrap steel, isn't it? You get money back? You do get money back. So it depends on what you get out of the structure, if you can sell it and make money off it. And that's what you should be looking at. So if you can keep this cost to be there, if you can reduce all the life cycle costs of it by having many cycles, then you reduce the total cost. It's called the Delft ladder. It basically means that you think more cycles within a cycle. As many cycles as you can think of. Is there a traditional product that people would have thought, I'll explain that in a minute. Is there traditional products where people would have thought of different cycles?
Yes, in our site we have done for the water tanks.
Okay.
Usually earlier it was laterite or the concrete tanks.
Okay.
For a very large one. The smaller in the households it is 1000 liters or 2000 liters.
Okay.
PVC tanks. But in our site what we have done, we have used a combination of a GA sheet, the roofing sheet, along with the inflatable balloon.
Okay.
So to the order of 1 lakh liter of water tank can be constructed very easily. Within a day it can be constructed.
Okay.
But the best part of it is the self dead weight is very less. Construction is very easy. And the dismantling and taking it out is very easy. Whereas in the case of the concrete tank and laterite, and a lot of accident has happened in the laterite and concrete tanks. So throughout the L&T now they have discarded this laterite masonry construction of water tanks because it is all of a sudden.
Yeah.
Whereas in the case of our this one, we are getting a lot of.
You can reuse essentially, and you can move it easily. Transportation cost is low.
And especially when it is in the hilly area, to take up the material above the hill, this has been very easy.
That's innovation, and that kind of innovation, you're probably innovating it because you have a greater need, or accidents are a good trigger for innovation as well. But that kind of innovation needs to come in at every level. And the more innovations you can think of at the beginning, the better the structure will be, and the lower the impact of the structure will be. Brilliant. Anything traditional, like in the past, your parents would have told you that we will continue to keep and use something? I'm just asking because Indian culture in the past had all of those elements. The way the farmers would have had 2 crops, rotation of crops, 1 crop. It's all just to looking at reducing the waste, using the waste from one to feed in the other, as well as putting the nutrients back in the ground. So it's cyclic thinking, rather than buying fertilizers all the time, which is expensive for them. It's not really great for the output or the yield. Anything else? Is there anything traditionally family-wise we just keep it? I don't know. I don't have the answer, so it's not a leaded question that we keep and we don't. No? Other than gold? No? You never dispose it unless to sell it. You buy it and you keep it, isn't it? So I wish if every material is considered the same way as gold, that you understand that it has a limited use, and you understand that not limited use, if you consider everything as worthy as gold, you will use less of it and you will be very careful in using it. Okay? I tell my students who are just about to write up that they should consider their words as worthy as gold. Don't just overwrite it. Write exactly what it needs to be written. It's an Institute of Concrete Technology saying, where they would say, just don't write the whole story by dragging it. Just tell that in a very concise, precise manner. Measure your words in equivalent gold value. Okay? Same concept in construction. And I take the view that I don't own anything. Everything is borrowed. Everything is borrowed. So as long as I can take it, use it, give it back, or give it to somebody who needs it, brilliant. And that's an ethos that you can apply in structures as well. So talking about the schools, every layer you can apply this end-of-life management philosophy. So you're looking at floor finishes, rating for suitability for reuse and recycling. Like we change floors much more faster than we change any of the structural elements. Okay. So in this school they were looking at steel covered, high density, for raised floors screwed into plinths with loose laid carbon tiles on top of it. So clearly the client requires you to have a meter square of floor, and they were asking which one will have the highest reuse and recycling potential, and they are asking you to outline all of them. So if you take one example at the top, they're saying suitability for recycling is such, suitability for downcycling, which means using it as something else, is such, reuse as new is that, and second-hand item is that. Why would a school or a shopping complex would look at things in that way? What's the driving force? Yes, but that's up to you to say everything will last the same service life. One of the requirements for all this kind of comparison is service life should be the same, functional area should be the same, output should be the same. Larger organizations do that because it makes them feel good. Corporate social responsibility. They do it because it gives them the credentials to say, we have considered sustainability as part of our brand new 40,000 square feet shopping complex in the middle of 100,000 other complexes. It is because it's a sales potential in it. It's because they, as a larger company, have a social responsibility. It is maybe because they don't want their impact to be much higher. Could be for right reasons, could be for wrong reasons. But whichever it is, the environmental legislations are driving it. They want to have a LEEDs rating or a BREEAM rating of such. It is part of their corporate social responsibility. So if they use solid wooden floor nailed to the subfloor, then it's saying the suitability under all of those criteria are high. Because wood is very usable materials everywhere. The only thing is the nail that they need to kind of worry about. But they're not using glue because that means they can easily remove it. They're also justifying that they can use rubber interlocking floor tiles, loosely laid, but have certain density that it'll just lie like that. So based on all of this, the client can then take a decision on what they want. So downcycling means if I use the table for the function of table, that's the use. If I use a table later on function of a ladder for construction, I'm downcycling it. Much later on, if I use that as a growing bed for my plants, I've downcycled it even further. Okay, so downcycling means I'm reducing the value of that product. By the function of it, by the use of it, it might get to that stage that it needs to be downcycled. So structural engineering equivalence is if you have a beam and you use the beam for, the best example is timber sleepers for railway. Timber sleepers are used for load carrying capacity or distribution of loading to the gravel. Once their life is finished, they're used to grow flowers or plants as a growing bed. Some people use it as a lintel in their house or whatever. It's downcycling. Lintel is not downcycling, but anything else is downcycling. Much later, people might come in with an axe, chop it and burn it. That's the end of that downcycling cycle. Okay? Unless they take the ash and put it back into the ground. So